Hi everyone, welcome to my FYP presentation. My title is The Refinement of Intermetallic Layer with Rice Husk Edge RHA as Silica source in thin copper solder on bare copper surface finished with laser soldering method. First of all, my name is Ong Zi Jiang and my metric number is 18993. I'm from the program of Bachelor of Mechanical Engineering with Honours. For the introduction part, the trend of miniaturization of printed circuit assembly causes inevitable innovation on soldering system design. Then we need to use lead-free solder to replace the lead solder with same quality finish. Previous study shows that SAC solders has the same quality finish as the lead solder, but the silver content, which is the precious metal that has unstable price, that makes the production costly. Then we need to retain the strength, to retain the mechanical properties to ensure the solder joint performance. In this project, my objectives are to investigate the relationship of RHA weightage in solder and the intermetallic compound thickness formed for multiple reflow, to determine the hardness of solder joint with laser soldering, to characterize the distribution of RHA in laser solder bulk ecosystem. These are the literature review that I've did for this project. This as well. To conclude the literature review, the thin 0.7% copper lead-free solder can save the cost without using precious metal. The RHA particles should reduce the IMC formation. Then, the laser soldering method should produce much thinner IMC compared to conventional oven reflow soldering. Here comes the methodology part. At the right hand side, this is the research flow chart that I've did. So firstly, there is literature study followed by the sample preparation. I did DSC and FASM EDS to determine the specific melting point as well as the RHA distribution, followed by the soldering process, which includes the laser soldering and oven reflow methods, followed by multiple reflow on bare copper surface, followed by the cross-section analysis, which I use metallographic preparation such as optical microscope and FASM EDX to observe the IMC, and then followed by the mechanical testing. I've used viscous micro hardness testing to obtain the hardness value of the solder joint. Lastly, all the data has been collected for the results and discussion as well as the thesis writing. This table shows the sample preparation for the ratio of thin copper and RHA for 4 different types of weighted percentage of RHA. This shows the process flow of the sample preparation. This shows the soldering procedures. So in total, I have 48 samples, 24 for the oven reflow soldering and another 24 for the laser soldering method. These are the methods I've used for the observation of results, which includes optical microscopy, the FASM EDX, spot identification and area mapping, and lastly, viscous micro hardness testing. Here comes the result and discussion. So the DSC results prove that the addition of the RHA will cause slightly increase of the melting point of the thin 0.7% copper solder. From the spot identification of the RHA powder from the FASM EDX analysis, this shows that there is silica, also known as SiO2, has been found from the RHA powder. This shows the RHA distribution. So to conclude this, the silicon or the RHA is homogeneously mixed with the solder. Here comes the wetting angle analysis. So this concludes that there are about 20% decrease or improvement of the wetting angle after the 0.1% of RHA addition. Same goes to the oven reflow method or the laser soldering method. So this spot identification of the FASM EDS result shows that there are 2 types of IMC compound found in the IMC layer, which are CO6SN5 as well as the CO3SN. These are the results under the optical microscope. So this is the thickness analysis under optical microscope as well. So the laser soldering method has a total thickness of 9.17 micrometer, while the oven reflow method has the total thickness of 15.81 micrometers. which means that the usage of laser soldering method has successfully decreased the total thickness for about 42%. This shows the hardness testing results. Although there is no very clear trend of the variation of the RHA, but we can conclude that the usage of laser soldering has higher hardness value compared to the oven reflow method. In conclusion, RHA addition produced melting range of about 18 degrees Celsius and a peak temperature of 235 degrees Celsius. The wetting angle has been reduced for about 20% with RHA addition. The multiple refill will increase the IMC thickness. The laser soldering will produce thinner IMC compared to oven reflow for about 42% after 3 reflows. There is no significant hardness difference for different weightage percentage of RHA, but the laser soldering has the higher hardness value compared to the conventional oven reflow for about 30%. In this project, my recommendation are to increase the RHA weightage percentage up to 0.2%. Maybe you can try on more surface trials as well, or use less reflective solder for the laser soldering, or use other alternatives such as solder preparation or solder paste, or we can study on the laser target temperature determination or calculation. And for the society implication, RHA usage is economically friendly and easily found. There are more advancements needed to compete with lead solders, and laser soldering has been becoming a trend in electronics production due to its automation and programmable ability. These are the references I've used for this presentation. That's all from me. Thank you very much.